Welcome back. We are going to start a new chapter. This is chapter 7. It's on exponents and radicals. Radicals is just another name for square roots, but don't worry about those just yet. The first part of chapter 7 deals with exponents. So you're going to learn a few properties about exponents today. And then tomorrow I'm going to do part 2 of this lesson, which will just be a continuation, and then the next lesson you'll have another property. So I don't want to bombard you with all these properties at once, so I'm kind of going to take it slow, introduce them to you, do some examples as always, and then have you do your assignment. Okay, and the most important thing is these properties are easy. However, I need you to still show me work. So yes, you can use a calculator, but the work is what I need to see. So let's begin. So we have two properties here. Now, don't get too carried away with the fancy names, but what I want you to notice is the word product, if you remember, is the answer to a multiplication problem. So in words, this is what it means. To multiply powers with the same base, you add their exponents. So for example, if you were to have 4 to the 6th power times 4 cubed, what the property says is the same base is the 4 and the 4. That's the big number. And all you have to do is add the 6 and the 3, which would make 9. So this would be your answer. Okay, but this property only works if the bases were the same. So you have an A and an A, so the base would still be an A. Okay, now the next one is called quotient of powers property. So if you remember, the word quotient is the answer to a division problem. Now, same base still applies. So to divide powers with the same base, you subtract their exponents. So if you look at this example, you have 4 to the 6th divided by 4 cubed. Well, the 4s are the same. That's the base. So if you subtract 6 minus 3, you would get 4 cubed, and this would be your answer. Okay, so these properties will only work if you have the same base. So let's do some examples. So pretty much in layman's terms, so let me break this down for you. If you look at this problem, so technically you have base of 2. Now, using this property, you should add. So if you would get, you have base of 2, that doesn't change. You have the little 2, which is your exponent, the little 3, which is your exponent, and you're getting 5. Now, I would actually need you to, either on a piece of scrap paper or your calculator, you would have to do 2 5 times. So it'd be 2, 2, 2, 2, 2, which is 32. Okay? And I'll show you exactly what I want to see on your homework. Now, this is why you add. Okay? So let's take a look at this. So if you have 2 squared, that means you have 2 2s, right? Now, if you have 2 cubed, means you have 3 2s. 1, 2, 3. Now, if you count those up, I see 1, 2, 3, 4, 5, which is the exponent that was right there. So if you really don't know these properties, you can still get these right by showing me all of the work. Okay, by actually writing out how many 2s there are. Okay, and then just count them up. Now, if you know the properties, then it saves you a lot of work. So if you look at the next one, again, layman's terms. So technically you should be subtracting, right? But let's pretend we don't know that. So let's look at this. So if you have 2 to the 5th power on the top, that means you have 5 2s. There are my 5 2s. Now on the bottom, you have 2 cubed. 1, 2, 3. Now, you want to cross off the same amount of 2s from the top and the bottom, because if you cross a 2 over 2, you're going to get a 1. So 2 divided by 2, gone, it's 1. 2 divided by 2, gone, it's 1. 2 divided by 2, gone, it's 1. Oh, look, what do you have left? You have 2 2's, which is 4. And if you use the property, 5 minus 3 gives you your 2. So again, these properties are very easy to memorize, but if you forget them, it's still very easy to get these answers correct. So let's do some examples. So let's look at this one. So if you look at letter A, you have 3 squared times 3 cubed. So you're multiplying here, so the property says to add. So we're going to get 3 to the 5th. Now, that's what I want. That's the work. But then I actually need you to do, either on your calculator or on the side of your paper, I need you to do 3 5 times. And if you do that, you'll get 243. So this is what I want to see boxed. I would like to see that you know that you should have added and then what the final large number would be. So let's look at letter B. Notice there are parentheses. That's going to be key. So the bases are the same, -4, -4. And it looks like we need to add these because it's multiplication. So you're going to get -4 to the 4th power. Now I'm going to show the work down here. This -4 means you're doing it 4 times. And that's why these parentheses are very, very important. Okay, so if you do a negative times a negative, and -4 times -4, you're going to get a positive 16. We'll do another -4 times a -4, which is another positive 16. And if you do 16 times 16, you will get 256. So again, this is what I would like to see boxed. Okay, you're showing me the property is addition, and then you're solving it and giving me the large number. Now, we can also do this with variables, but there's actually less work with variables because you don't get a large number because it's a letter. So take a look at this one. They all have x's, so they all have the same base. So all you have to do is add 2, 4, 6. So if you add 2 plus 4 plus 6, you will get x to the 12th. And that is your answer. You can't actually keep going with that problem. Now, if you look at letter D, that first 5 does not have a showing exponent. However, you boys should know there is a 1 right here. So the 5s are the same. That's your base. So 5 to the 4th because we added. Now I need you to actually on your calculator or on the side of your paper do 5 to the 4th power, which is not 20. Remember, it's 5 times 5 times 5 times 5, which is 625. Okay, so these properties were all that when you have the same base and you're multiplying, you're essentially adding the exponents. So now let's do some examples of when you're dividing. So you're going to use the quotient of powers property. So let's look at letter A. The 4s are the same. Those are your bases. So you're going to be subtracting 6 minus 3, which is 3. So you showed me that you know the property. Now you need to do 4 times 4 times 4, which is 64. This is what I would like you to box for me. Okay. Oh, the next one's easy because it's just the letter X. So you're going to subtract because they're both X's. So 9 minus 8 is just X to the 1st. And if you remember, you could simply just say it's X. Go ahead and look at letter C. The 3s are the same, so we are allowed to use the property. So you got 7 minus 4, which would be 3 cubed. Again, you actually need to do that for me. 3 times 3 times 3. which would be 27. Go ahead and box that. Last one, you've seen parentheses before. So the negative 4s are both the same base. So we're going to do 8 minus 5. And we're going to get negative 4 cubed. Now, just like we did before, that's negative 4 times negative 4 times negative 4. So if you do negative times negative, you're going to get a positive 16 times a negative 4. So your answer will be a negative. And it's going to be a negative 64. So this is what I would like to see boxed. Okay? Now the next property is by far the easiest one, and there is no work for this property. So this one deals with when you have a 0 in the exponent. So it's called the zero exponent property. It's very clever. So this is what it says. If you have any number or any letter that has a 0 as an exponent, it will be always a 1. And if you don't believe me, you could actually pull your calculator out and plug in a large number and raise it to the 0th exponent, and you will still get a 1. If you don't believe me, I know some of you will actually try to prove me wrong, but I am right, as most of the time. And it could be any negative number. So no matter how small or how large the number is, if it's raised to a 0 exponent, it will always be a 1. And it also holds true for any letter. So you could have A to the 0th, B to the 0th, anything, and it would still be a 1. And there it is. Basically, any number or any variable raised to the 0th power is equal to 1. So let's do a few examples, and then I will give you your assignment. Here we go. So simplify each expression. Well, 3 to the 0th, 1. X to the 0th, 1. Negative 4 to the 0th, 1. Extremely easy. So anytime you see a 0 in the exponent, that answer would be a whole number of 1. So there's no base anymore. So the 3 disappears, the X disappears, the negative 4 disappears. And your answer is simply just a 1. Okay, so I created a worksheet for you that's going to contain all these 3 properties. Again, show me the work that I expect. There's no work for when you do ones like this, and you should get them all correct. So there's your assignment, and I will see you boys tomorrow.